In this presentation, we will understand how chirp signals and pulse compression are used in radar and sonar. A sonar system needs two important things: strong echoes for reliable detection and fine range resolution to separate nearby targets. A chirp signal helps us achieve both. Presented by Professor Gottapu Sasibhushan Rao. Let us first understand the basic problem. A short pulse has a small pulse duration. So, echoes from closely spaced targets are less likely to overlap. This gives better range resolution. But a short pulse carries less energy. Therefore, the received echo is weaker and the SNR is lower. A long pulse is the opposite. It carries more energy and gives a stronger echo, so the SNR and detection range improve. However, echoes from nearby targets may overlap, resulting in poor range resolution. So, with a simple pulse, there is a trade-off. Short pulse gives good resolution but low SNR. Long pulse gives high SNR but poor resolution. Chirp overcomes this conflict by transmitting a long, high-energy pulse and then compressing it at the receiver. Chirp generation and pulse compression. Now let us see how chirp signal works. A chirp is a frequency-modulated pulse whose frequency changes continuously with time. In an up-CHIRP, the frequency increases from a lower value to a higher value during the pulse duration. Because the transmitted pulse is long, it carries more energy and gives better SNR. At the receiver, the echo is passed through a matched filter. The received chirp is correlated with the known transmitted chirp. This compresses the long echo into a narrow peak. The compressed pulse width is approximately inversely proportional to bandwidth. Therefore, a larger bandwidth produces a narrower compressed pulse and better range resolution. So, long pulse duration gives high energy and SNR, while large bandwidth gives fine range resolution. This is the main advantage of chirp pulse compression. Benefits in sonar. Finally, let us see why chirp is useful in sonar applications. A long coded pulse provides more transmitted energy and improves the received SNR. A large bandwidth gives finer range resolution. Pulse compression produces a narrow peak, which allows the echo delay to be measured more precisely. As a result, weak targets can be detected more reliably, even in the presence of noise and reverberation. It also improves the useful detection range. Therefore, chirp signals provide both reliable detection and accurate range measurement, making them very useful for sonar navigation and target tracking. Thank you.